I continue our part modeling with the next part. We have made the frame part, and the next we have a shaft part. In this shaft part, we have many details on it. Here, what I'm going to do is, we do not see too many details on this view. I will only adjust my view to this part view detail here. What I'm going to do is I will just make the new part again with standard millimetric inch part, standard inch with the dimensions. I will save this time my part with the part 2 with dash shaft. Here we have a shaft detail with the holes here. We have a lubrication hole here, and we have some thread details with the MPT, which is the taper tool, taper thread detail on our part. We have this pulley is to be lubricated, and this is the lubrication channel through the shaft and the pulley itself. Here, the next thing, also we have some adjustable tools on this place. We have an undercut at this point. We have an undercut at this point. We have also another second undercut at this point, and we will do this one with the shaft details by manually. I'm not going to make a shaft detail, only I will just consider this shaft as a normal part with a revolve section here. But I will use some other details about this one, if I can find some details about our shaft here. We do not have too many details about this one. I will go, and one by one, I will create the features. The first thing I will just create and make visible of two items. One is the origin point and the XY plane. Here I will start a sketch on XY plane. I will create the first line with center line properties. Here I choose this point as my origin. Okay. The next thing, one by one, I will zoom in detail, and we will go to this place. I will start sketching this detail. We have an undercut at this point. I will do the same thing for my figure. I'm sorry. I'll create a new line, which is this one. We have a chamfer detail at this point. We have a line, and this time, I'm sorry, I have a vertical line, and here I have some details about our figure. Yes, like this. We have a hole detail, and this hole detail is not very true about this one. We will make adjustment about this detail. It is not very clear about our part details. The next thing, what I'm going to do is I will just continue to modeling. We also have another undercut point here. This line is this line, and we have an undercut at this point, which we will go like this. And this undercut have different dimension. Here our dimension is 1.2 inches, and after this undercut we will continue with 1.06 inches. Here, what I'm going to do is I will continue again another undercut with this dimension, like a short one, like this one, and I will go in this detail. Here, what I did is I will go start from this point. I have a chamfer here, go inside, go to this shaft detail. I will go under the cut with a new shaft detail. This is the part which I have just drawn so far. I have this one to be here. And after this point, I go this undercut and continue to here. This time I have this undercut, continue to here. Next thing, I will go to this detail. Up to this point, I will just clear the figures. And this time, this shaft detail will go through this point. And we have again, we have again an undercut. And this time, undercut will continue with a threaded length. With a threaded length, which is in 1 inches. Here, our thread, the bolt or the nut used at this point is 1 inch with 12 with the UNF 2A, which is the ASME B1.1. I will use 1 inch for this dimension, and for here we have 1.6 inch at that dimension. Okay, we will continue our modeling. After this point, we have a step at this point, and we will continue to this point. Here, this line, our center line, is a solid line, and I will just extend this one and make the trim. Then I will continue to give the dimensions which I have seen on the drawing. At last point, we have, at last point, we have 1 inch diameter from here. I will use this one, I'm sorry. I'll take my move back, which is this one. It is 1 inches. And I will go again to zoom out. And we have 1 inch segment length for this part piece. This is the 1 inch here. After this part, we have 1.6 inches. Here we have 1.606 inches, not 10, it is 1. And this length is 2.6 inches, which is this one. It will start at this point and it will end at this point. The dimensions are very confusing. If I have made a mistake, I will correct this dimensions in the technical drawing section after I have put all the objects to each other in the technical drawing. Okay. The next thing, we have 2.6 inches. Okay. The next thing, we have an undercut, and this undercut, I do not know this dimension. Here, I have an undercut at this point, which is down besides of it. Here, we have a vertical constraint. If I have made a mistake about this one, I will just leave this distance about 0.05 inches. Just for in case, I will delete afterwards when I found the dimensions on the table of our part here. The next thing, actually, I will just correct that dimension from the metric size because I do not have the table and I do not want, because I'm going to change this one. You will see this dimension, also the length of this undercut, let's say 0.06 inches for this dimension. I will change these dimensions in the technical drawing of the submission. The next thing, we have a 3-inch dimension from this undercut, this point, which is this point, and it will just go to the shaft dimension. Again, I will give some dimensions, which is 0.06, and from this point to this line, which is 0.05, I will use these dimensions. We have a diameter dimension here, which is 1.2. The dimension here, we have 1.2 diameter. And from this undercut dimension to this part, we have a 3-inch dimension. We have extended this dimension. The next, we have 0.16 inches. From this point, we have 0.16 inch. I will use this dimension tool to have 0.16 inches. As you see, we have a lost that chamfer relationship. Also, we have 1.8 inches diameter for our part here. I will zoom out and put the dimension from this line to this line, which is 1.8 inches. When you look to our part, I will just take it back to here. As you see, we have all the dimensions so far. The next thing, the missing thing here, we have 0.06 inch chamfer. You can ignore this, or you can just make 0.06 inches with 45 degrees dimensions. Okay. The next thing, what I'm going to do is I will finish my sketch. At the end of this part, I'm going to add the threaded section here. And for this hole, we have 2 holes here. I'm going to add those holes. For ease of operation, I can just make this hole with the sizes which I have seen here. For this, I will just sketch this figure to my figure. Here we have a pulley drawing, a pulley axis for to be lubricated. And this pulley has a width of 3.2 inches, which is this distance is 3.2 inches. I will clear my drawing and I will go to search for the dimension of this whole location. Here we have 3 inches. As you see, we have a 3 inches. Probably it is in the middle part of this part of our drawing. We have a hole at this feature, which is between the same point here. For this reason, it is not to be dimensioned. For this, I will just create a new line in this sketch. Okay. a new line. And this line will begin at somewhere in the on this line. And here I get the midpoint of this line. And I will change this line properties with the dimension here, which I have seen at this point. I will go around this point here. Because I'm going to revolve this hole around this dimension. And I will use, I'm sorry, I will just clear this line for turning purposes. You can also delete and get this other side. Anyway, we will have the same thing, the same dimension, which is 1.2. This is the whole dimension. But if you want, you can also make this rectangle bigger than our part, like this. In order to not to make the confusion, we will use this line, or you can just delete this line. We have many alternatives. I will change this center line and get this center line point, midpoint coincident on this line. Also this center line to be on this line. And here what I'm going to do is I will just give this dimension here, which is 0.328 inches. I will use 0.328 inches. It will just make a cut operation inside of it. Okay. Here, to see the detail about this one, when I will use this line, I will use this point to be passing through other side. For this, I will use this line to be this line. For whole purpose, for whole length, I will use this length. I'm sorry. I will use again. I will take it back, split this line. Okay, this is the line. It is figured here, as you see. There is no movement in our figure. Only just lose the symmetrical condition. When I have just redefined the symmetric condition, I have this line property. Again, the same thing for other part with this line. Okay, this is my whole dimension, which is this point. Okay, at least I have to go around somewhere between, which is 1 or 0.06 inches, which is approximately 1 millimeter far from this whole length. I will clear and show where we were, what we would like to do in the future. Here, what I'm going to do is I will use this line. This line belongs to this line, and the whole depth, this point, will be this point. Okay? Here, what I'm going to do is I will clear everything, and I would like to get the whole depth point by having the trim operation. I need this point to be on our figure. I do not use this line. For this, I'm going to choose the construction purposes. I'm going to use the other lines as well. Again, I will just zoom out and create my part file. Also, we have as you see, we have another hole at this point. Here we have another hole at this point. I will take my sketch, and here I have that detail. I do not have that detail around this one. Here I can just think that we have at the midpoint of our plane, which is 1.4, and which is this time I have 0.7 millimeter far from this bolt here. We have a threaded hole. As you see, I will just zoom in. We have a threaded hole with 1 inches. We have some details, but here we have a bushing part here, which is this one, which is this one. I will just hatch this point. Here, what I'm going to do is I will just mark this part on the assembly part. If you do not want to, just make a calculation about this one. We have 1 inch, and after 1 inch, we have a question mark, which passes through this point. For here, I will just use that dimension for this bolt connection on the top side. Our bolt here with the 7 number, we have a bolt here, and that bolt is about 0.5 inches, which is 1/2, a half-inch diameter bolt on the top side, and it is length will be about the 4 inches at least. Okay, we will use those dimensions for our figure in the part. Okay, let's continue the modeling. We have finished my sketch. I have first make the revolve tool, then the holes, and then the other features as well. Here, I will just, I'm sorry, I have the revolve tool, select this line, this one, to be revolved around this axis. Okay. The next thing, we have 1 inch thread. From the modify tool, I will go and get the thread this time for this face and check the thread specification here. I have 1 inch size. That is true. Yes, exactly, it is true. But the thread designation is not true. I need to get 12 to UNF 2A. 2A is the class here. This is the 2A. UNF is the fine thread dimension. And with the 8 is the number of threads in an inch length. Here I'm going to change the thread with 1 inch to -12 UNF with 2A class. Normally our thread is right hand thread. Okay, this is our part drawing. Also, you can just mark another rectangle tool to make a cut for the 1/2 inch diameter hole here. We would like to have, I have forgotten that one. First of all, I will change this to center line, and get the dimension to be dimensioned about 0.5 inches. I finished my sketch. To use those sketch, I will just go and have the visibility of our part here. Okay, next. The next thing, what I'm going to do is I will revolve and this tool around this axis to make the hole with a cut operation. I'm sorry, revolve, cut, the profile here, the axis turning this one. I will make with an angle. I think I have just, okay. There's no need for this. Okay, anyway, I will use that sketch at the end. I will clear my annotations. Let me try again to just realize what I'm doing wrong. This one, this is the axis. We have a full round axis, okay. This is the cut. Anyway, start a new sketch for this plane with F7 tool. I will get the geometries, these geometries I need. Finished my sketch. Have the revolve tool. First, I will just close this sketch. Visibility, I need only this one. Have the revolve tool. As you see, we have that axis. We have a hole at this point. Again, this time I have just created this hole feature here. The hole at this point. The next thing, we have a hole around this point here. What I'm going to do is I need a 0.321 inches with a taper thread at this point. We will do this operation in 2 steps. The first thing, I'm sorry, clear. The next thing, what I'm going to do is I will just create a hole at this point. But to see where it will end, I need this line, which I have marked when I'm sketching. For this, I will go to View, with Half Section View, get this one. I need this point to end our thread here. What I'm going to do is I will go get a hole command. I will use this point. I have the hole. From sketch, or you can use the coeccentric. I will use this face and I will use this point or this axis to be on this one. We have a blind hole, not a true hole. We have a distanced hole like this one. And we would like to also use the to command. The to command will just satisfy our point. Here I need the point which I have created at this point. Here, what I'm going to do is, I wonder if I can change, select this point. Anyway, for this point, I will just create a working point around this point. Again, I will just take the whole command again. start a coexcentric on this plane or on this face first of all, and as a coexcentric reference I will use one of the circles here, and I will change the dimension of our hole, which is 0.328 inches, which is this one and this one, because the leader just touches to two places. For this, I may understand our hole dimension is 0.328 inches. With two commands, I'm going to just select. We have a conical end at that point. If you want, you can also just have a taper hole like this. And this taper hole will have a NPT fitting, pi PT. NPT, we have an NPT fitting, which is 0.18 inches. And it will result about, if you have just calculated this time, it is not this dimension. We have a termination, or we can just have a normal thread hole dimension with two commands, and we will just use this point. If I can just select, okay, it is not selecting actually. We have a working point, but it's not working. Okay, let me measure the distance with measure tools. Measure. This point is this point. The distance is about 1.914 inches. I will just record and write this whole dimension to somewhere else here. What I'm going to do is I will just again create a hole, this time the dimension with MPT. Also, I would like to use a calculator to find the diameter of our figure, which is 0.12 inches, and it will result to somewhere in our drawing. Here we will continue about our hole creation. We have the hole tool. Our hole tool has an MPT starting at conical one. Here we have different sizes with 0.12. You can change the dimensions and you can check our diameters here with the MPT sizes, which is this one for 1/4, which is this one. We will have an MPT diameter about this one. Here the distance we are interested in is 1.94 inches, and we will continue with a coexcentric hole creation. We will use this surface to start. We will use this coexcentricity about our hole creation. When you look from this side, as you see, we have the hole with MPT start, which is 1 divided by 8 with 28 NPT here. I will just click OK and create the part file here. The next, I will just close and save this part with the dimensions shown. Also, I would like to create another hole, and I will just create that hole with another sketch on XY plane. Again, have the visibilities, get the project geometries of our part, drawing, finished my sketch. I will adjust those dimensions, which is this time we have the right dimension, but the location is not correct. We can just adjust this hole by using the dimensions. When I just press the update button, the project geometry will disappear under the main part. What I'm going to do is I will just create a revolve tool and just remove material from our part. This is the 0.5 inches hole diameter for adjustment bolt. Here I will just go back to view, or if you would like to just work on the part, you can just save this view as the sectional view. Section, this is the section. You can lock and you can take it back to the view back. We can just switch between the views. Okay, I'll save this part. We will continue with the next part. Okay, the next thing, we will continue about our next part, about the pulley part in our figure. We have a full round part here. We have some material removal inside. Also, we have a ball shape here. We can just, we are going to make the first modeling part, and we will remove material from inside of our figure. I will just clear and adjust my figures side by side. Okay. Our next part is the pulley part. For this, I will just open a new part. On this one, I will open a new part, a standard inch part here. I will create a profile, which I have seen here, with the profile seen at this point. Also, I will just include these points. Ignore these corners. These, I will use these tools with the other features. And for this, I will just create those dimensions from our figure here. What I will do is I will just create an outline profile, something like this. I will revolve this profile with an eye profile around this axis. And after I have revolved, I will just close the sketch. And after that one, I will create the part. With 2D XY plane, I'll create a normal line. This time, I'm not going to use this one, center line properties with construction properties, and I will move sketch this part to be about around the midpoint axis here. I will create the profile which I have drawn previously.